All right. All right. So in this particular problem, we are asked to find the area that is between these two concentric circles. Okay, so that means the area of this space I am shading now. Okay, so first of all, what are concentric circles? So concentric circles are circles that have the same midpoint. That means they have the same center. So in other words, it's assumed that these two circles have the same center. All right, so now let's try to make some constructions here. So assume that this is a line running through from the circumference to the other circumference and then to the center. Let's take it that this is a point. Okay, so let's assume that the center is 0. Okay, so we can as well construct another line from this point to this center also. Okay, so you discover something, and that is that let's take it that the radius of the smaller circle is r, and then the radius of the bigger circle, that's this one, is small r, so let's call the bigger circle big R. Okay, now there is a theorem that says that if there is a line that runs from the center of a circle, that it bisects any chord of that circle. So this is a chord of the circle, so that means this radius is a perpendicular bisector. So that means this distance is 8.5, which is half of 17. Okay, so recall that this line is also our R. Okay, that's the big R. Okay, so in other words, from here we can clearly see that if we consider this particular triangle by Pythagoras rule, our big R, the square of it will be equal to the square of small r plus the square of 8.5. Okay, so from there we can get that our r squared, if I pull this to this side, it will be minus small r squared is equal to 8.5 all squared. Okay, now of course, if we try to get the area of the shaded this portion in between the two circles, that's going to be the area of the big circle minus the area of the small circle. Now meanwhile, the area of the big circle is going to be pi times the radius of the big circle squared. Okay, so that means the area of the small circle will be pi times the square of the small radius. So if we subtract these two areas, then we will get the area of the portion we are looking for. Okay, so in that case, the area we are looking for is going to be equal to, so here I can actually factorize pi, and then in bracket I'm going to have r squared minus small r squared, and which was why I had to do this subtraction here. So our area that we are looking for is equal to pi multiplied by this particular r squared minus small r squared. We saw it as 8.5 squared. Okay, so by the time you simplify this, that will give us approximately 227 cm squared, and that is the solution to this problem.